Okay, class, it's 17:35. Time to start. Please confirm audio visual is clear. Screen is visible.
Yes, sir.
Yes, sir.
Okay. Guys, again, yesterday we were discussing whether some question should be there or not there in chart work. This is definitely one of the questions which should not be there. Okay. But unfortunately, it was in one of the very recent papers, and it was in one of the older papers also. So we used to cover it in the class because it was there in the old papers. And many people again felt came across this problem in last it was in not last to last exam, and that's why I had to make the video and post it after that. I had shared this video with you yesterday. I hope you have seen it. I just want to discuss so that you do not have any doubts as far as this question is concerned. Okay, just to hedge the risk in case it is asked again. That's the only reason. Otherwise, no, not a good question for exam for sure, because too much of geometry, why should it be involved, and why should we go about in circles to fix, is something difficult to understand, but unfortunately it's an exam question, so let's leave it here. A vessel steering a certain course, so the course is not known, with a speed of 12 knots, observes the following at 1900 hours. Govan Head 260 degrees compass, Keldy Island 080 degrees compass. Saint Gowan light vessel was 30 degrees on her starboard bow. At 1930 hours, she find the same light 60 degrees on her bow. Find the position of the vessel at 1900 hours and the course that she was steering, compass course. Of course, the chart will give you true course, and then it has to be converted to compass course. That's last part we are not going to discuss. Now, in this case, some part of the plot has to be on the answer sheet, because without that you will not be able to do. We do not know the compass error, so obviously bearings cannot be converted to true. We do not know the CTS, so this relative bearing cannot be these relative bearings cannot be converted to true either, because we do not know the CTS. What we can definitely get to know is, with this we can get a position circle by horizontal angle. Yes or no between this pair? Correct, beta?
Yes, sir.
Now, what is the horizontal angle between them, beta? How much is the horizontal angle?
180 degrees reciprocal
And
bearing.
yes, and when horizontal angle is 180 degrees, it becomes reciprocal bearing. So here you will get actually a PL by reciprocal bearing.
We will
So
get a
you get
PL
a,
line, not
sorry,
portion, sir.
beta,
We will get a
sorry.
PL. We will get a
Yes,
PL line.
so we started with PC by horizontal angle. When we got the horizontal angle, we found it to be
180
we
degree.
found 180 degrees, and that's why we said it's a special case. It will be a PL by reciprocal bearing, right? But that we reached the conclusion only when we calculated the horizontal angle, right?
Yes, sir.
Yes or no?
Yes,
Okay.
sir.
Now the other two relative bearings, 1900 and 1930, 30 degrees on bow, starboard bow, and 60 degrees on the starboard bow, we cannot convert them to true because the CTS is not known. So there is a fair bit of drawing that you have to do on the answer sheet. See now this part. This is Saint Gowan. You can see here. Saint Gowan is here. This is Gowan Head, and that's your the third one, Chaldean light. Okay, so you have the 3 points here. So what do you do first, guys? You see, in the answer sheet, this whatever you are seeing in this blue box, you'll have to do it on the answer sheet. Okay, working on the answer script. 1900 Govan Head and Keldy Island lights are on reciprocal bearing, giving you a PL. We have to obtain a PC by distance for 1900 from Saint Govan light vessel. And how do we find that? You see, this is Saint Govan light vessel. Let us say the vessel is steering this course. Let us say this is the CTS. At 1900, this Saint Govan light vessel is 30 degrees on the starboard bow. So that means the vessel would be somewhere at point A, and this angle is 30 degrees on the starboard bow. After 30 minutes, that is 1930. This Saint Gowan is 60 degrees on the starboard bow. Let us say it reaches point B, where now it is 60 degrees on the starboard bow. Everybody's understood up to this point, guys? So I've just plotted some CTS, which I do not know, but then it will be 30 degrees on the starboard bow and then it will be 60 degrees on the starboard bow. Am I right, guys? Correct? Right, guys?
Yes, sir.
Yes, sir.
Now, if this angle is 60 degrees, this angle will be 120. And if this is 120, this angle will also be 30. So this angle will also be 30 degrees here. Now, guys, the vessel continues on this point and comes to see where the light will be abeam. Now the light is abeam here. Okay. Now you see in this case, beta, because this angle is 30 and this angle is 30. So in this triangle XBA, this side and this side will be equal because it's isosceles triangle, the angles are equal. What is the distance A to B? A to B is the engine distance in 30 minutes. What is the speed of the ship? 12 knots. So distance AB will be 6 miles. Better mute yourself if you're not talking to me, please. Seelam, please mute yourself. Please mute yourself. So A to B will be 6 miles. And if A to B is 6 miles, then X to B will also be 6 miles. Okay. So this is how we'll first get this thing. So let me just clear it and show it to you again. Now, AB is 6 miles because that is the engine distance in 30 minutes. And XB will also be 6 miles then because XBA is an isosceles triangle. Now, if XB is 6 miles, angle B is 60, then in this right angle triangle XCB, we can find out the beam distance by simple trigonometry. This is the theta 60 degrees. This is the perpendicular and this is the hypotenuse. So sine 60 will be perpendicular upon hypotenuse. So you see here, XC, the beam distance will be XB into sine 60. And this way we can get the beam distance XC as 5.2 miles, 5.9196, or you can say 5.2 miles. Understood, beta? Yes or no? Am I clear, guys? So we get this beam distance as 5.2 miles or 5.196 miles. Is that clear to everybody or any questions? Clear, beta?
So this 6 miles we actually got, no, sir, that distance.
Which one?
The 6 miles.
Which
AB
one?
and AB and XB, sir.
Got from where?
From the chart, sir.
You have just joined, is it?
No, no, sir.
So how did I say why was AB taken 6 miles?
Sir, I missed that part, sir. Sorry.
Engine speed for 30
The
minutes.
12 knots was the engine speed.
So why AB was taken 6 miles? That's my question.
Because the plotting done on 30 minutes.
Because vessel had this light 30 degrees on the starboard bow at 1900 hours and 60 degrees on the bow at 1930, so half an hour, right?
Half an hour. Okay, sir. Okay, sir.
And then why XB was 6 miles?
Because isosceles triangle, sir, 30 degrees, 30
yes,
degrees.
yes.
Yeah,
So
okay.
once you get XB, now can you get XC? 5.2 miles or 5.196 to be more precise. Plotting it will be 5.2 only, of course. Correct?
Yes, sir.
Now, guys, once I have got XC, now I deal with the bigger triangle. Which bigger triangle? XCA. XCA. This is also a right angle triangle. This angle is 90 degrees. This is the theta. I know this side of this triangle. Now I can find out the hypotenuse. This is the perpendicular, this is the hypotenuse. What will be sine 30 equal to? Sine 30 will be equal to xc, which you already know, divided by xa. Yes or no, beta? See, it is coming on the screen. XC is the beam distance 5.196. Now, XA will be equal to beam distance upon sine 30 because sine 30 will be equal to beam distance upon XA. And you get this distance X to A as 10.4 miles. Yes or no, beta? Please let me know. Arshad, you didn't watch this video yesterday at all, is it?
Sir, I actually forgot, sir, in the middle of the class.
Yeah, so
Yes.
don't miss out things, my friend.
Yes.
So guys, XA is 10.4 miles. Does everybody understand?
Yes.
What was point A? Point A was the position of the vessel at 1900 hours. What is X? Saint Gowan light vessel. That means at 1900 hours, the ship was at a distance of 10.392 miles from Saint Gowan. Is my inference right, guys? That the ship was at a distance of 10.392 miles from Saint Gowan light vessel. Yes or no? Guys, if anybody is not understood, please let me know. A is the position of the ship at 1900 hours because that time the Saint Gowan is 30 degrees on the starboard bow. And so XA is the distance of the vessel from Saint Gowan at 1900 hours. Am I right in this plot on the answer sheet? Am I right, guys? Bolo bhai.
Yes, sir.
Yes, sir. We'll get
Yes, sir.
Okay. So what has it given me? It has given me the distance of my ship from Saint Gowan light vessel at 1900 hours. And when I get this distance, this becomes the radius of the position circle with Saint Gowan light vessel as the center. Because through this geometry, I have been able to get the distance of my ship from Saint Gowan. XA is the distance of the ship from Saint Gowan at 1900 hours. Right? So this will give me a position circle. Why? Because if my distance is 10.4 miles, then with Saint Gowan as the center and 10.4 miles in radius, I can draw a position circle, yes or no? Because this is the range I have got. Am I right, guys? Now I go to the plotting sheet. First, I have a position line by reciprocal bearing. You see it's come up here. This is the position line by reciprocal bearing. Now I open my compass 10.4 miles, 10.392 miles. Put my compass at the light vessel and cut on this line. And wherever that cuts, that will be the 1900 hour fix. Does everybody understand now? Yes or no?
Yes, sir.
Okay. So what does he want? Find the position of the vessel at 1900 hours. So you can transfer the latitude and longitude of this fix onto the answer sheet. Then he's asking, what was the course steered? Now, guys, on this course, when I continue, what is the beam distance of Saint Gowan light in our plot? Can you tell me from the plot what is the beam distance?
5.2.
5.196 or 5.2 miles. That means whatever course I was steering doing from here, when I reach I reach a point where Saint Gowan is a beam, I'll be at a distance of 5.2 miles. So what do? I open my compass 5.2 miles, put my compass at Saint Gowan, and I draw a circle here, not a position circle. I draw a circle with 5.196 or 5.2 miles as radius and Saint Gowan as the center. Now, if I draw a tangent from this light or this position onto this line, then when I am at the point of tangency, this light will be a beam and distance will be 5.2 miles. So when I draw a tangent from here, I will get my CTS that I was doing. This will be the required CTS. This will be the true CTS, right? This will be the true CTS. You can take it onto the compass rose, measure it. And of course, the question wants compass scores. Now, true scores will have to be converted to compass scores. That is what we had studied in the first lecture. Is this plot now clear to everybody? I've already shared the video. You can see it again. This was asked in last to last. So if you leave the last paper, the one before that, this was there in the exams. It was there in one of the earlier exams also. So we used to cover it in the tutorials. And our boys fortunately were able to do it. But then I thought I'll make a video and post it so that everybody can use it. Is this question clear now, guys?
So is this topic about this finding the missing leg, missing course? Like
No, yaar, it is not a missing leg. You, it is like it is only one thing which is missing. In missing leg, usually you'll have two things missing or something, right? This is like like if somebody says find the position, then will you say call it as missing leg or missing position? No, you're finding something, right? If you want to put it in that category, you can put it. I don't want to classify because it entails this geometry not required actually. This is something which is honestly not required in the exams. So you'll have to do this part on the answer sheet. I have always told you no plotting to be done, but this calculation you'll have to do it on the answer sheet. There is no escape from it. Is that clear, beta?
yes, sir.
Okay. So you can watch the video. Video is already with you. So I'll close this. Guys, I have put about 6-7 questions. Out of that, this is the third question I've shared with you so that if there is any doubt in these tricky questions, you can clarify with me. But you can always watch the video anytime. Okay, I'm closing it, guys, then, if there are no more doubts. Okay. Okay, we go to first topic for the day. Single PL navigation or blind navigation. Now, why it is called single PL navigation or blind navigation, guys? That it may happen someday that you manage to get one PL and nothing else. And you do not have radar, you do not have anything. You are completely blinded because of restricted visibility. So then it's called blind navigation also. And then based on this PL, if you can continue your safe passage, then that will be called a single PL navigation. That means you are using the single PL to keep moving, making some progress of the voyage using single PL, but ensuring the safety of the vessel. Now, let me at the onset say, because then otherwise, Praveen, you still have a problem with your audio? Are you still with two machines?
Yes, sir.
क्यों क्या हो गया तेरे को?
लैपटॉप पे ना माइक नहीं है माइक के
mic you were supposed to get repaired, no? That was 4 days back. You said I'll get it repaired.
Yes, sir.
तो क्या हुआ उसके बाद?
नहीं हो पाया सर माइक का अनइंस्टॉल करना पड़ेगा सर इसको लगता है
तो अनइंस्टॉल कर लो 4 दिन में इंस्टॉल करने में कितना टाइम लगता है?
ठीक है सर
Okay. So guys, now before Rahul or somebody questions, sir, every PL can be used for this purpose? No. The PL has to be suitable. Of course, if it is asked in the exam, they'll give you a suitable PL. I'm talking from shipboard actual application. So can every PL be used? No. The PL has to be suitable. Now somebody may say if the PL is not suitable. Now guys, if you don't have a suitable PL, you are completely blinded. You don't have any effective navigational aid coming to your rescue. Then as a master, what will you do? As a master, you will reduce your speed to bare minimum, hold your position wherever you are, and stay till the situation improves and you can continue with your voyage. Okay. So if the PL cannot be used, it cannot be used. It's not necessary that every time you'll be able to deploy this method. So when a method is learned, does not mean it applies in every situation and you can use it whenever you want. No, it is a part of knowledge which you are carrying, and in case circumstances it fits into a given scenario, you are able to use it. Okay. Needless to say, if it is there in the exams, then you will have this. It will be a suitable PL, but on board the ship. Secondly, it will be totally master's discretion whether he wants to continue with the voyage or not on a single PL. Why? Because he has to ensure that the safety of the vessel is not compromised. Safety is not compromised. Okay, this is the reality. But since in the exam somebody will be testing you academically, then the PL will be suitable. And if such a thing comes, then you'll call it as a blind navigation or single PL navigation and deploy the method that we shall learn now. Any questions about the introduction to the method, guys? Any questions you would like to ask about the introduction to the method?
Okay, sir.
Okay, now. What all would be given in such questions? In such questions, you will be given one PL. Now, PL can be celestial, PL can be terrestrial, PL can be by radar. You have a PL. Then you will have some position, best possible, whether it is estimated position, allowing estimated wind and current, or it is DR, whatever best you can get. That something you will also know around that. Okay. And then you will know the engine speed. You will know the current and wind in the region, if any. And this is what all you, and of course, you'll be given some indication where you want to reach or how much distance you want to clear a given landmark or a hazard. So those indications would be given to you. So what will be given to you in such questions is a suitable position line by any method that we have learned in the first lecture. Ship's DR or EP or a position through which the PL is drawn. This last part will of course apply for the celestial PL. Ship's engine speed has to be given to you. Current, wind, both, one, none, as the question wants. This all will be given to you in the question, guys. What can they expect you to find? They will expect you to find the first CTS, time when you alter the course, and the second CTA. Maximum they can ask you to find these three things, or two, or any one of them. Nothing more than this can be found or answered in this question. Okay. The question, since it's single PL, there is nothing else given to you. The question will be very clear that it is pushing you to use single PL navigation. Okay. Such questions usually do not have any doubt. Now, I'll not take you through the procedure. I'll explain, because when you read the procedure, it'll unnecessarily confuse you. Let me take you and I'll explain to you through this example. Okay. At 2000 hours, a vessel in DR lat 51 degrees 35 minutes north observes Ballycotton Island light bearing north. So obviously this will give you a PL. The vessel is without operational radar and GPS. Visibility suddenly becomes poor. So you're blinded. Master decides to reduce speed to 10 knots and safe along the safe courses. Safety is of utmost importance. And what so that he can pass the mine head 10 miles off. Find what should be the first CTS the vessel should set sailing upon. B. What time should she alter the course? And what should be her second CTS? Current in the region was setting southeast at 3 knots. Wind northerly, wind northerly, causing a leeway of 2 degrees. Okay. So this is the question. Here is the question, guys. Now, what have you done? This is the 8 o'clock PL that you know you're south of this Ballycotton Island light. Okay. Now, in exams, the PL will be suitable. In real life, I told you, every PL may not be suitable. So don't unnecessarily push yourself on board the ship that I will use single PL navigation. Single PL navigation is subject to the suitability of the PL and, of course, the approval of the master. Now, this is the PL. Now, you want to pass 10 miles off the mine head light. Mine head is somewhere here. So if you have to find past 10 miles off, you'll open your compass 10 miles and you'll draw a circle like this here. Yeah, am I right, guys? Yes or no? Of 10 miles radius, correct? Right? Now, you can transfer this PL because it's a suitable PL. It is specially made suitable for the question. You'll transfer this PL tangential to this circle. So guys, if you move along this transferred PL, will you be passing mine at 10 miles off? Yes or no? Correct?
Yes.
Okay. Now, the vessel's DR latitude was 51 degrees, 35 minutes. This was the DR latitude. And of course, the PL here is coinciding with the meridian because it is running north-south. So in this case, I am not saying I am at A. Guys, I am not saying I am at position A. I am not saying it is the ship's fix. Ship can be anywhere on this line. We do not know where the ship is. Okay. Now, I want to safely reach in the shortest possible time from line 1 to line 2. These two lines are parallel to each other. And in geometry, we know that between two parallel lines, the shortest distance is the perpendicular distance between them. So through this point A, if it was not this dr lat, then dr would have been given. Or if it was a celestial PL, we'll take the position through which the PL was drawn. I draw a perpendicular distance between these two PLs. And I will see if this can be the course made good. If this can be the course made good. Why you have taken perpendicular distance? Because you do not know where on this line you are. So you want to minimize your exposure to hazards, and therefore you want to make good the shortest distance to reach on the transferred PL. And the shortest distance will be a perpendicular distance. Therefore, you have drawn this. Now you'll say, is perpendicular distance always binding on me? No. It is, of course, subject to being safe for the vessel. So what do you now do? You do not know whether you are at A, but most probably you are somewhere in this region. So what will the master do? Master will draw a safety margin on both sides to allow for the error in position here. And then he will scan this entire region to see whether it is safe for my ship or not. Why? Because when I have a safety margin or safety zone on both sides, what am I ensuring? That whatever may be the error in my position here, I expect myself to be navigating in the safe zone which I have surveyed. Now, your next question that will come is, sir, how much should be this safety zone or safety margin? Guys, in reality on board the ship, it will be master's call. What all factors will master take into consideration? First, he will take into consideration the reliability of a DR or this DR let in this case. What will decide the reliability of the DR? DR is always worked from a last known fix. So if this is a 2000 hour DR, suppose my last fix was at 1900 hours, then my DR is reasonably reliable. But if my last fix was 5 hours back, then the reliability of the DR also decreases, because more the interval that passes, more will be the possibility of error in the DR. Do you agree with me? Yes or no, guys? The reliability of the DR depends on which was the last fix used for calculating the DR. If the interval is less, reliability of the DR is higher. If the interval is high, the reliability will be lesser. So, and the master will also decide upon what is the condition of my engines, which side is the wind, what is the competence of his officers, what is the traffic density. Master will take into all these factors and decide whether the safety margin should be 4 miles, 10 miles, 15 miles, or maybe master can take a call. He doesn't want to continue with the voyage. He'll hold his position wherever he is. That is his call. Coming back to the exam, you will ask me, sir, how much safety margin should I take? It is only a recommendation, guys. I would suggest a 4 to 5 miles margin on either side. It is only for exam purposes. On the ship, I have told you the factors which will drive this, and that will be completely the discretion of the master. Am I clear, guys? Am
Yes,
I
sir.
clear, beta?
Yes, sir.
So what will you do? You will draw the safety margin on this side and safety margin on this side. And whatever I have shaded, this entire zone, you will scan, see very carefully whether this entire zone is safe for your vessel or not. If assuming that this is safe, then this becomes your first CMG. If it is safe, then this becomes your first CMG. Have you understood what have I said? Yeah. No, you can't try that. I can't give you any explanation for 4 to 5 miles, better. You're just demonstrating that you know that this position A is not the ship's position. Therefore, you are just exercising due caution by having a safety margin, right? I cannot give any explanation why I am choosing 4 miles or 5 miles. There cannot be an explanation to that, right? It's an arbitrary thing which I just suggested to you for exams. Right? Yeah, because explanation is when something can be justified. I can't justify 4 to 5 miles. Tomorrow somebody can say no, 4 to 5 miles is too much or too less, right? Okay. Now, assuming that this is safe, if it is not safe, we'll see later. Assuming this zone is safe, then this A to B becomes my first CMG. Okay. Now you'll say, sir, so now what is the distance I have to make good to alteration point? Which will be my alteration point then, guys? Which will be my alteration point?
B.
Point B.
But B may not be the point I reach. I'll reach B if I start from A. But notwithstanding A and B, how much is the distance made to be made good to alteration point? AB. Yes or no? Correct? Correct, beta?
Yes, sir.
Now suppose
Without the time.
suppose my vessel was not at A. Suppose my vessel was here at C. There was error, right? What will happen? I make good the same course. Instead of reaching B, I'll reach D. But my distance made good now becomes CD. The distance made good has not changed. Only the points have changed, but the distance made good has not changed. Do you agree with me? Yes or no?
Yes, sir.
So when I am saying alteration, I'm not saying alteration point. I'm not saying B is the alteration point. No. B will be the alteration point if the vessel was at A to begin with. If the vessel was at C to begin with, then D will be the alteration point. We do not know which will be the alteration point. We only know that the distance made good to the alteration point, wherever it is, will be same in both the cases. It will correspond to distance AB. That's all. So now, guys, if I know the first CMG AB, I know I have wind, I have current. To get first CTS, will I counteract them or will I allow them?
Counteract.
Counteract.
And if I have to counteract, what do I counteract first?
Correct.
So it is back to your knowledge of triangle and current. So you counteract current first. Where do you apply current? You'll apply at A or B?
A.
Point A.
Sir.
Point A. So current is setting southeast. So I draw a southeasterly current. I don't have any requirement of any specific period of half an hour, 1 hour, or 2 hours. So I'll make a triangle for 1 hour. I'll take the drift for 1 hour of 3 miles and I'll cut it here at D or C rather. Or X. Let's say this is XY. So let me say this C. Now I'll open my compass equal to engine speed, engine distance in 1 hour, which is 10 miles. I'll put my compass at C and I'll cut it on the CMG line and I get D. Please think and speak. Don't rush with the answer. What will be the direction C to D called?
Leeway track.
Leeway track.
Effective
Very,
course.
very good. Effective course or leeway track, whatever it is. You can take this to the compass rose and read the effective course or the leeway course or leeway track, whatever it is. So many degrees true. Wind is northerly. So wind is northerly. Now I'm just doing here. To counteract wind, do we go into the wind or do we go down the wind?
Into
Towards
the
the
wind.
wind.
So we go into the wind. Will this CTS reduce or increase if I go into the wind?
Reduce.
Reduce. So minus 2 degrees and you'll get CTS so many degrees true. This is the first CTS that you will do so that you are able to make good course AB. And when I'm saying AB, I'm only talking of direction. So this will be your first CTS, and on that you will be able to make good a course AB. Now I'm again repeating. I'm not saying I am at A. I could be at X, but even if I'm at X, I will steer the same course. I'll make good the course XY, and after the same time, I will reach the transferred PL. So in each case, I'll reach the transferred PL at the same time, notwithstanding whether I'm at A or I'm at X or some other position. Am I right, guys? Yes or no?
Yes, sir. Yes, sir.
Now, guys, how do I find the alteration time? I have to make in how much time will I make good distance AB? Steaming time to alteration course alteration will be equal to how much distance is to be made good? AB. Look at the vector triangle. What is the speed made good?
AD.
Which
Delta.
very good, AD. And this gives me the time after which I can alter the course. If I was at A, I'll reach B and alter the course. If I was at X, I'll reach Y and alter the course. But the time will not change. It will remain the same. Have you understood, guys? Clear? Clear, beta?
Clear, sir.
Then the second CMG will always be along the transferred PL. Second CMG will always be along the transferred PL, either in this case northwards or southwards. In this case, you can see it will be north. So this will be the second CMG. Now, if this is the second CMG, then I can find the second CTS by counteracting wind and current. So now I'll have to draw the current at B. I draw the current at B. I cut off drift for 1 hour. I cut off engine speed for 1 hour,
12 miles. Yes.
उधर भी रखे हैं.
10 miles, and then P2Q is my second effective course. It is the second effective course. Am I right, guys?
Yes, sir.
And then I'll have the northerly wind, leeway 2 degrees. I go into the wind. This course will increase. Am I right, guys? Yes or
add.
no? Here the leeway will be added, and we get the second CTS. And we get the second CTS. So I have explained you the procedure. Now I'll show you the same thing which is plotted on this. Let me clear the handwritten stuff here. And then if you have any doubts, do let me know what is coming to your mind. You see, this is the circle which I have to, this is the clearing circle with mine had a center and 10 miles as radius. This is my transferred PL parallel to this, tangential to the circle. I have taken this is the DR lat, so this is my first desired CMG in the vicinity of my best position that I can mark. Then I have drawn these two safety margins. I scan the chart. I find that this entire safety zone is safe for me. So this becomes my first CMG. I counteract current on it and I get the effective course. And on the effective course, I will counteract wind and I'll get the first CTS. CD is the effective course. AD is the speed made good. AB is distance made good to alteration position. From this, we can calculate the time required for the alteration. That will be equal to AB upon AD. Then we have to find the second CTS, second CMG in this case is northwards. We counteract current at B and we get the second effective course. And on this, we'll counteract the wind and we'll get the second CTS. Simple, guys, or you have any questions coming to your mind? If this zone is not safe, we'll talk about that in a while. But if this zone is safe, is that fine with everybody? If this zone is safe, then it's fine.
Yes.
प्रवीण समझ में आ गया? ये बाद में कुछ और तो नहीं पूछोगे इसमें? प्रवीण
नहीं सर, आ गया सर समझ में.
ओके.
यस सर.
और परसों वाला किया तुमने रिवाइज?
हाँ
Did you
सर,
revise?
परसों वाला किया.
Okay, ठीक.
Yes, sir.
Okay. Guys, I didn't ask you, but I'll ask you after I finish the topic. If anybody has any doubts in first 3 questions of revision assignment, and if you do not have, then please complete the revision assignment before the next class, so that if you have any doubts, I can take up those doubts with you. So guys, this is the way we can do it if the zone is safe. Okay. Suppose this zone was not safe. Let's come here. I draw this safety zone and I find this is not safe for me. Okay. Suppose guys, let us say here was the DR lat. Okay. Suppose there is a island here. No, obviously, guys, I cannot be taking this course here, or even if the island was little north, let's say, why have it in the way? We can have it little cleared off also. No problem. Let's say this is the DR north. Let's say there is some hazard out here. Okay. Now, guys, if I insist on going on a perpendicular track, then this hazard lies within my safety margins. and I'm not comfortable making good this course. I will, because why? If my position instead of A is at B, then guys, I have invited trouble for myself. Okay, so I will not venture like this. This perpendicular CMG is desirable, but it is not binding. Why it was desirable? So that you make good the minimum distance between the two lines. But it is not binding at the cost of safety. If safety becomes an issue, then minimum distance is not binding on me. Okay. So in such a case, what could possibly be done? Again, final call is with the master. If he's not happy, he does not move. That's fine. Let's say there is a problem here. Now, you will see what are the conditions. Guys, current is southeasterly, wind is northerly. You see the effect of this is southeasterly, this is southerly. Guys, you can, I'm sure everybody will agree that it will be foolhardy to venture like this. It will be foolhardy to venture like this in this condition. Why? I'm not talking of tangent. It need not be tangent. But it will be foolhardy to go like this because better mute kar lo. Because if my engines fail or something, the wind and current can create trouble for me. Am I right, beta? Yes or no? Correct, beta? Okay. So what would I do if I want to continue with the thing? This part of the plot remains unchanged. Only thing is now what will I do? I will draw a CMG somewhere like this. And then have a safety margin on both sides. Make sure that this zone is safe. And then this becomes my first CMG. Now in this case, everybody is going to get a different answer. Everybody will get a different first CTS and alteration time. Why? Because somebody will draw like this, another person will draw like this. The courses would change. So don't worry, you have to stick to your own plot. Okay. So first CTS, everybody will get differently depending on where you have plotted the CMG. Alteration time, everybody will get differently because the distance to be made good will be different for different people. But second CTS will remain the same because ultimately the second CMG will be this only. Second CMG is not going to change for anybody. Is that clear, beta? And if second CMG is same, second CTS should also be same barring the plotting errors. Am I right? Yes or no? Is that clear, beta?
So second CMG may be
Sir, doubt.
disturbance.
Why second
Disturbance.
CMG will be different? Second CMG will be along the transferred PL only, na beta? Why will the second
sir.
CMG be different?
If there is an island in second CMG also.
Then you will not navigate along single. You will not use this option of single PL, na beta? Then you don't see unless you read why you are using the transferred PL, because you know that if you are here, you will reach somewhere on this line. If you don't want to use this also, then you can't use this method, Rahul.
Yes, sir.
Yes or no?
Yes, sir.
Okay. Now, basically, you see, you are not using it without PL. This PL is a line on which you will definitely be after some time. But in the absence of PL, how are you going to ensure your safety? There's nothing that will ensure your safety. Then you are just taking a blind shot. If you succeed, you succeed. And if you fall, you fall. So
basically sir, क्वेश्चन में सेकंड पीएल में कभी भी कोई डिस्टरबेंस मतलब कुछ
अरे
island वाला नहीं है।
अगर तुमने उस पीएल को यूज नहीं करना तो फिर then what are you using the PL for? Nothing. Yes or no? The purpose of transferring the PL is that you want to make sure that you are along a PL which was observed. It may have been transferred, right? Yes or
sir.
no? So if you don't want to use the transferred PL, then how do you know that where are you? Then there'll be nothing that will guide you through, right? There's nothing ensuring you giving you the safety, right?
Right, sir.
So second CMG will always be along the transferred PL, guys. So don't have any doubts on that. Okay.
Sir, doubt.
Yeah, tell me.
So instead of, can we go to the previous slide?
Tell me what is your
जहाँ पे
doubt.
आपने island,
अरे तो doubt
जैसे we
बताना
had
यार.
the island, जैसे we
Hmm.
had the island, sir, can we not take the point A slightly southerly and go on a horizontal CMG?
No, but how much south will you take? That will depend on you. You can see what you are doing is you are saying that yeah, I'm somewhere in this part. Yes or no?
Yes, sir.
Now, if the whole idea is yeah, that you're trying to use your best known position, right? Best known position, which may not be the correct position. Correct,
Correct, sir.
beta? So that is
Correct,
the
sir.
that is the issue. Correct.
Like what
Now,
I'm
now if
saying
you say
is,
no, what I'm saying is you'll say I'll come south here on this PL, right?
correct, sir.
Correct. And then you can definitely go like this. There's nothing stopping you, but the problem is you do not know. Suppose instead of here, if you're somewhere somewhere again here, then what happens outside the safety margin? Correct.
Yes, sir. Correct, sir.
So you're just trying to make a beginning from the best possible point, right? Again, this A is the best possible position that you can use, right? The moment you leave A, then there is no end to these possibilities, na beta?
Yes, sir.
Okay.
Understood, sir. Thank you.
Okay, now guys, do this question. Read this question. This is already in the assignment I've shared with you. A vessel is in DR position 51 degrees 35 minutes north, 8 degrees west DR at 900 hours, obtains an intercept 4 miles towards azimuth 110 by the sun's observation. The visibility thereafter becomes near zero. Assuming that the vessel's electronic navigational aids are non-operational, find the following if the vessel decides to steam at 8 knots. Current in the region was 150 degrees at 3 knots. There is no wind mentioned. So now guys, if you see in this case, what will you do? You will plot the DR. You will get the PL by intercept. So you'll draw the azimuth of 110. You have intercept of 4 miles. And this will be your PL, right, beta? Am I right? Marked by single arrows. This is the PL at 900 hours. Am I right, beta?
Yes, sir.
Yes or no? Now, in this case, you will explore your possibility of the CMG from which point? From the point through which the PL has been drawn. Through which point PL has been drawn? PL has been drawn through ITP. Yes or no? Correct, beta? PL
Yes,
has
sir.
been drawn through ITP,
Yes, sir.
right? Now, if you go to the chart, I'm just explaining it to you. The pilot ground is somewhere here. You want to reach the pilot ground. As I said, the PL has to be suitable. So now, guys, if I transfer this PL through the pilot ground, then if I can reach the transferred PL and then steam along this PL, I should be safely reaching the pilot ground. So through this point ITP, I will draw a perpendicular distance that will coincide with the azimuth. Let me name them just for the sake of discussion. AB. I will draw the safety margin.
Is it necessary to draw from ITPs or anywhere on the lines?
But ITP is the best known position now. See the question what I've been always saying, best known position, best position that you can consider, right?
Yes, sir. Yes, sir. Okay, sir.
Okay, so in case of celestial observations, it's the point through which the PL has been drawn, right?
Yes, sir.
Correct? Again, they are not the fixes, but that is the best bet, right?
Okay, sir. Okay, sir.
So now AB is the first CMG provided it is safe in the safety margin. Don't have to shade that. If so, now you can counteract current, get the first CTS, get the time when she reaches. And then at B, you will, this will be the, better mute yourself. This will be the second CMG. And you can counteract current on that. I have a plot of one of the students here from the previous batches. You better mute yourself, Ram, or somebody who's unmuted. If you're talking at your end, please mute yourself. Guys, this is the plot from one of the students who has shared in the last batch. You can see here what has he done. This is, I think, the DR. Sorry. Let me just go. Achha. This is, I think, is the DR, guys. This is the azimuth. This is the ITP. And this is the first PL he has drawn. Somebody like you from the previous batch shared this. Then the pilot boarding ground is somewhere on this side, guys, up north. This PL has been transferred, but he has not marked with double arrows. Please mark at the ends with double arrows to represent that it is transferred PL. Now through ITP, he has drawn the CMG. From A, he has come to point D. Then he has marked the safety margins. You can see he found the region to be safe for navigation. Then he has counteracted the current, got the first CTS. Alteration time, steaming will be equal to distance AD divided by AC. And that will give you the alteration time from plus 9 o'clock is the departure time. So you'll get the alteration time. This is the second CMG, is counteracted current on it. And you can see this is the second CTS. There is no wind. So whatever you get in the triangle is the CTS. Is that clear, beta? Clear, class?
Clear, sir, clear.
Okay. I'll clear it off if you want to take a screenshot or something. This is somebody, some student had done it and then shared with me on the group. So I've just taken it that way. Okay. So that brings us to the end of this single PL navigation, guys. If you have any questions to ask, let me know. Otherwise, single PL navigation is done. What you can do now is, it's 18:32. You can take 8 minutes break. Think of some question if it comes to your mind. At 18:40, we will start with the second topic. Okay. Take a break till 18:40. I'm just muting myself. If you have any questions on single PL navigation also, you can ask as soon as we resume the class.